Assalamualaikum and hi everyone. Before this, we have discussed about the structure in C++ programming. Okay, now we are going to learn about the class. Okay, so technically, structure and class are almost equivalent. Okay, before Microsoft developed the C++, they started with the C language. Okay, C language, and during that time they use the structure. Okay, and then when they upgraded to C++ language, they introduced the class. Okay, so loosely speaking, it is some sort of programmer's preference. Okay, some prefer to use the structure, okay, and some of them favor the class. Okay, in fact, you can have structure in your class. Okay, so but somehow, however, there are a significant difference between both of them. Okay, so they are alike except for this one here. Okay, so members of class are private by default and members of structure are public by default. Okay, so if you look at the code at the left hand side here, okay, so this code is using the structure. Okay, and this code works fine. Okay, but somehow on the right hand side here, okay, it uses the class. Okay, and this code at the right hand side here didn't work. Okay, because of this thing here, the private and the public thing here. Okay, so on the left hand side, you can see here you have the member integer x. Okay, so by default, x here is public. Okay, any member in the structure, okay, is public. It means that the value of x here, integer x here, can be used anywhere. Okay, can be used anywhere in the codes. Okay, so that's why when you have t.x here, okay, so t.x equals 20. Okay, so it means that you don't need to redefine, okay, or redeclare x in the integer main here. Okay, but somehow here the integer x here by default is private. Okay, it means that, okay, in the integer main here, in the function main here, we cannot use the x. So when you have t.x here equals 20, so this is where the error comes from, because the program cannot recall, okay, what is x, okay, because by default it is private. Okay, so we need to do some modification to this program 2 here so that it can work. Okay, so we want to maintain with the class rather than structure, but okay, we want to make it work. Okay, so we'll see, okay, how do we modify this so that, okay, the compiler, okay, can successfully run, okay, this code. All right. So what we need to change in program 2 so that it can work is this part here. Okay, so this integer x here, which is a private in default, need to be changed to public. Okay, so we need to rewrite. Okay, we need to add the public here. Okay, so we have class test, okay, and then we write public. Okay, so now the x here, the integer x here is public. It means that it can be used anywhere in the codes. Okay, so the public means members are accessible by functions outside the class. Okay, whereas for the private, members are accessible only by function inside the class. Okay, so we can see here the function main here is not a member of the class test. Okay, so that's why, okay, if we put integer x only, it cannot be accessed by the function main. Okay, but when we change to the public, okay, so the function main now can use the integer x. This is the common way or common syntax to write a class in C++ programming. Okay, so we start with a class, okay, and put the name of the class, any name that you prefer, and then we declare the members, okay, inside the class. So we put all the variables that we want to have and state whether they are private or public. Okay, so by default, if we didn't put the public or private, so by default they are assumed to be private. Okay, so if we want to make it public, then we need to put the word public here and then follows with a colon. Okay, and then anything inside the class here is called members. Okay, so members of a class can be variables, okay, also can be structure and also function. Okay, each member are global and its scope is either private or public. Okay, so this is the example of class with the name P. Okay, so we have a class P here that consists of a variable x, okay, which is private. Okay, also consists of 3 functions. So whenever you have the open and close bracket here, okay, so they're actually referring to the functions. Okay, so in the class P here, we have, okay, a variable x, okay, which scope is private, and we have 3 functions. Okay, function P, function, so this is what we call the destructor, tilde P here. Okay, so after this we will see what it means by the destructor here. And then last one here we have the function Q, okay, void Q. Functions, okay, which are members of the class, have the scope of public in this case. So it means, okay, they can be accessed by the non-member functions including main. Okay, so you can see in the class P here, the void main is not stated. Okay, so okay, in your code, you have the void main. Okay, so normally we have the void main at the bottom of our codes. Okay, so in this case, this function main here is not a member of class P. Okay, so by default, okay, in the void main here, we cannot use the integer x. Okay, so basically we cannot have m.x, for example, okay, because x here is private. Okay, but somehow we can see, okay, the function P is public, the function Q is also public. Okay, it means that the non-member functions can access P and Q because they are listed in the public mode. Okay, so for example, in the void main here, we have m.q. Okay, so this part here is working because Q is public. Okay, so in order to access the function Q here, okay, so the same as in structure before, we use the dot operator. Okay, we use the dot operator to link the object to the function. Okay, so since the structure and class are pretty much equivalent to each other, so we will see how do we convert the previous codes that we have, okay, in the structure part. We want to convert to the class now. Okay, so this is what we have before, okay, the use of structure. So now we want to convert into class. Okay, so we just change the structure here to be class. Okay, and then this one as well. Okay, so you will see you have many errors here. Okay, so the curly lines here, they are basically denote your error. So if you run this program, you will have error. Okay, because of by default, again, by default, the members of your class here is private. The DD, MM, YY, okay, the employee name, the salary, they are all private. Okay, and you can see the function main is not in the class. It's not in the class employee, also not in the class date. So uh, by default, the void main cannot access any members in the class date or in the class employee. Okay, so to make it work, okay, we must um, uh, put or we must rewrite the members here to be public. Okay, so what do we need to do? We just put the word public and the colon. Okay, so once we have that, so we can see now, okay, no more curly line. Okay, so it should be working now. So if we run this one, okay, so it works like before. All right, so they're very simple. If you can understand the structure, okay, so most likely you will know how to use the class as well. Okay, so all right, another special features that the class have are the constructor and destructor. Okay, so what I have in this slide, the constructor P, destructor tilde P, and the function Q here are actually referring to the previous slide that we have. Okay, so in the previous slide, we have a class uh, name P. Okay, and inside the class P, you can see you have the function Q. You have this one, which is the constructor, and tilde P here, which is the destructor. Okay, so the constructor and destructor is a special features that we have in the class. Okay, in the structure, we don't have the constructor and destructor. So what is the constructor? Okay, so it is a special function which has the same name as the class. So if you name your class to be my class, for example, then the constructor will be my class, open and close bracket. Okay, similar to the destructor, it should be with the same name as your class. Okay, but for the destructor, we have the tilde sign. Okay, so in the constructor, the program actually allocates the memory for the class. Okay, and it is suitable to put or to initialize the global variables. Okay, so we put all the variables that we want to use in the constructor. Okay, and in the destructor, it is actually for deallocate the memory from the class. So it means that after we execute the program, okay, the destructor will automatically release the memory. Okay, so in that case, okay, we can save our machine memory. Okay, so that's the special about the destructor in the class. Okay, and the function, okay, a function or the functions, okay, because we can have multiple function in the class. Okay, so they are actually referring to a block or module or unit of work in our program that can be called anytime for solving a given problem. Okay, so a function must belong and declared into a class. So it means that we need to put inside the class so that it becomes members of that class. Okay, so for example, you have, for example, the matrix A. Okay, so for example, you are given or you have a matrix A. Okay, so from that matrix A, you want to determine the determinant, and you also want to find the inverse to the matrix A, and you may want to get the transpose, for example, transpose of matrix A. Okay, so in the function in the class, we may want to define, okay, every task that we want to do in terms of individual function. So we may want to have void D, for example, for the determinant. Okay, void inverse in void I for finding the inverse of matrix, and then the void T, for example, for the transpose. Okay, so what do we have later in the function D? Okay, so we are going to have void D, and then inside the void D, we put all the instruction on how to compute the determinant. Similarly, okay, in the void I, okay, so we put all the algorithm, the codes to find the inverse of the matrix. All right. So in this way, okay, it is now easier for us to manage our codes. Okay, easier to manage. Okay, and it looks nicer. Okay, or in other words, okay, later whenever you want to modify, for example, you only want to modify in the determinant part. So you just look at the void D, okay, and then modify that certain block only. Okay, or and then it is also easier for us to trace any mistake or any error. Okay, so rather than put everything in the void main, okay, so by using the individual functions, okay, we can create, okay, individual block, okay, in our codes. Okay, so that's the use of having a functions in the class. This is the skeleton program of how our codes may looks like. Okay, so we start with the pre-processing area. Okay, so these are the pre-processing area where we create our class. Okay, define all the members inside the class, follows with the constructor. So you can see you have my class one more time. Okay, because the constructor need to be the same name as our class. Okay, so you can see in the class my class, you define the constructor and destructor, and individually in the codes we have the constructor part. Okay, similarly for destructor, okay, so you have my class tilde my class. Okay, and here's the function my function. Okay, so you can see we have the void my function. Okay, so we define my function to be the member of the class my class. Okay, and then we have the individual block for that function. Okay, so we put uh, everything that we may want to have inside the function. Okay, so in this example, in the void my function, we just want to display a sentence. Okay, and the main body, okay, is the void main. Okay, so in the void main, so you can see here we have my class P. P is basically the object. Okay, so we define one object to the class my class. Okay, so why do we need the object here? Okay, is for us to access the members in the my class. Okay, so we have P dot my function. Okay, so when the program execute P dot my function, so it will go automatically to this function. Okay, so at the end, okay, what we are going to display is just a line entering the object-oriented world of C++. Okay, so the skeleton program consists of pre-processing, functions, and the main body. Okay, let us understand the global versus the local variables. Okay, so in this example, we can see that in the class my class, we define integer x and y here to be public. Okay, so it means that the x and y are visible everywhere in the codes, okay, in the program. Okay, so you can see in the constructor my class here, you have x equals 5, y equals -7. Okay, before this we have seen that in the constructor we normally declare the variables, okay, that we want to have in our code. Okay, all right, and then look in the void main here. Okay, so we can see that we use somehow p.x and p.y here. Okay, this is valid, okay, because we have defined the x and y to be public. Okay, but somehow the void main is not a member of the class my class, but we can still access the x and y because they are public. So how do we access the x and y? Is by using the linking operator, the dot operator. Okay, so we have p dot x and p dot y. Okay, in contrast, so look at the integer z here. So z is defined only in the void main. It means that z is a local variable. It only can be used in this block only, okay, in the void main only. So we have integer z, okay, so z equals p dot x times p dot y. Okay, so that's how we differentiate between global and local variables. Okay, so for example, if you put integer x comma y comma z, okay, then z becomes a global variable. So you don't need to declare one more time in the void main. Okay, so and then look the difference between the function my function, okay, and the void main. Okay, so in the my function, you can see you use the x and y automatically without the dot operator, whereas in the void main, in order to use the x and y, okay, you need the dot operator, the linking operator. This is because the my function is a member of your class, my class. It means that the integer x and y can be used directly in the void my function without the linking operator. Okay, and the void main, which is not in here, so that's why we need the linking operator. Okay, so I hope you are clear on the global, local, public, and private. Right. All right. This is another example or illustration on the private and public mode. Okay, so we can see, okay, in this part, in this class, we have two part, okay, the private and the public part. Okay, so we can see here we declare these variables to be private. So R, V, A, X, Y, and Z are private. Okay, and in the public mode, okay, we have the constructor sphere, destructor, tilde sphere, and also three functions: radius, volume, and surface area, okay, are in the public mode. Okay, so for these private variables, okay, they are only accessible for the members of the class sphere. Okay, so we can see where we use these variables. Okay, so we can see we have x, y, and z here. Okay, we also have r, x, y, z in the function radius. We have the v, the r, okay, in the function volume, and then we have a, r in the function surface area. So in these functions, okay, in all of the functions here, you can see we can directly access these variables, okay, because these functions are members of the class sphere. Okay, so that's why we can access these variables without the linking operator. We can use directly R, X, Y, Z, and so on. Okay, so it means that these variables here are visible everywhere. The everywhere here actually referring to the members of the same class, in the same class. Okay, except in the main. Okay, so look at the main part here, the void main. Okay, so we cannot access the private variables here. Okay, so it means that if we have, for example, s dot r, s dot a, still it didn't work because they are private. Okay, but somehow, okay, in the void main, you can see we have s dot radius, s dot volume, s dot surface area. These are valid because radius, volume, and then the surface area are declared as public mode. Okay, so that's why they are accessible. but they cannot be used directly. It needs to be used with a linking operator because main is not a member in the class sphere. Okay, so that's why we need the linking operator to access the public functions in the class sphere here. Okay, so that's the difference between the private and public mode. Okay, so in the void main here, okay, for this example, we completely cannot access R, V, A, X, Y, and Z because they are private. Even though with the linking operator, we still cannot access them because they are private unless we put them under the public mode. Okay, so I hope you are clear on that, and we'll see more examples on the private and public mode. So in some sense, we can say that, oh, in that case, to be safe, always put the variables to be public. Yes, you can think of that, but sometimes in a big scale programs, sometimes we only want to have local variable, sometimes we only want to have a private variables, okay, and some of them, okay, can be declared in terms of public. Okay, but for small scale, to be safe, okay, to avoid the errors here and there, you can put everything as public. All right. Okay, now look at the concept of data passing between functions in classes. Okay, so data passing is the process of transferring the data or argument from one function to another. Okay, so in this slide, you can see you have the function f and also the function g in the same class, which is my class. How do you know? Actually, by looking at this, my class, and this is also my class. So you know that both of f and g are member for the same class, which is my class, but one of them is integer type and another one is the void. Okay, so now I will explain why do we have integer here and why do we have the void here. Okay, so when we run the program in the function g here, so we have integer r, and r is equal to f. F is the function. So when we run the program will find where is the function f. Okay, because the value of r comes from the function f, because r equals f. So we will go to the function f. So inside the function f here, so we have integer a, b, p, where a is 3, b is -5, okay, and p is a plus b. So at the end of this line here, we know that p equals -2 because 3 plus -5. Okay, so at the end of the function f here, we have the value of -2. Okay, so we have the value. So that's why we need to use the integer, because we return a value at the end of the process in the function f. We have a value that should be written to the one that requests it. So the function that requests the P is the function G here, because in the G we have R. Okay, R equals to F. So it means that whatever value that we have at the end of the function F here, okay, will be written to the G, okay, because at the first place, G requests the F, the value from the F, okay? So the value of P is written to the function G that will be assigned to the R. Okay, so it means that at the end of the process, R, okay, receives the value of -2 from P. Okay, so now it should be integer here because the function produce a written value. But here, the void here, okay, we use the void here because G do not produce the written value. Okay, instead they are requesting from another function. They are not producing the value. So we just use the void. Okay, so similarly, for example, if A, B, and P are data type double, for example, so for example, you have A equals 3.5. So P would be double. So you change everything here to be double. So in that case, you need to use double here, double my class. Okay, so the choice of integer, double, or void is basically depends on the n value, okay, or the value that you have at the end of the process. Okay, if at the end you produce the double value, then it should be double here. If you do not produce anything, you are not returning any value, then it's just void. Okay, so you can refer to the previous codes that you have in the previous slide. So see, okay, some of the function you have the double in the front. Okay, and for the main, for example, you only have the void main. You don't have the integer main. You don't have the double main. Okay, because you don't really produce anything in the function void main. All right. Rules for data passing between functions. Okay, number one, both the passing and receiving functions must be declared with the same prototype. Okay, number two, both the passing and receiving functions must mesh in their argument types and prototypes. And the last one, functions other than void must return a value. That this is what I've mentioned in the previous slide. Okay, so look here. So your programs, the main program starts here, okay, in the void main. So we have sphere S. So S is the object to the class sphere, and you have the double R here, double R. What is R? R equals S dot radius. Okay, so the value of R basically comes from the function radius. So we'll go to the function radius. So this is radius. Okay, so this one here, the radius R, okay, R equals dot radius, and this function radius here, okay, must follows this rule. Both the passing and receiving function must be declared with the same prototype. So R here is double. We declare as double. So when it goes to the radius here, okay, because R, the value of R comes from the radius. So here R is double. So in the radius, the written value should be double as well. So it means that if the function radius here, if you put integer here, then you'll get error. Okay, because the declaration of R here is double. Okay, where the R comes from the function radius. So in the radius, the written value should be double as well. Okay, so what do we have in the function radius? So we have the small r, the value of x, y, and z. So at the end of this function, we have the value of r, which need to be written to the capital R because R requests it. R is equal to s dot radius. Okay, so we know that the function radius must produce one value at the end. So that's why we use double here instead of void. Okay, because of this rule here. Functions other than void must return a value. Okay, if you use the void here, then it cannot be passed to the one that requested. Okay, so in order to pass the data, we need to have this word here, return R. Okay, so similarly for this one, s dot volume. Okay, so the volume is, okay, so s dot volume R. Okay, so it will go to the volume. Okay, now for the illustration of this second rule here, the second rule says that both the passing and receiving function must match in their argument types and prototypes. Okay, so here, look at the S volume R. Okay, so S volume R, so it'll go to this. So in the bracket here, so it means the volume carry the value R, the value of capital R. Okay, so before this, okay, before this line, we already have the value R because R is already obtained by the radius. Okay, so whatever value that you have here will be carried in the volume. So for example, R at the end of the process here, R is 1.2 for example. Then you will carry S dot volume R means S dot volume 1.2. Okay, so you bring that value to this. So in the volume function, it should be, okay, matched in the argument types. Okay, so here the volume, and inside the bracket it carries one data type, which is R. So here in the function volume, it should also carry the same or match with their argument types. Okay, since R here is double, so it should match here. It is also double R. So if the value of capital R is 1.2, so it means we have volume 1.2. So inside the volume function here, so we have volume double 1.2. Okay, so it means the calculation here is V equals 4 times pi times 1.2 times 1.2 over 3. And at the end of the process here, we'll get the value of V. Okay, so this value of V will be written to the S dot volume. Okay, so this is for this illustration. Both the passing and receiving function must match in their argument types and prototypes. Okay, for example, if we have here volume and inside the bracket here we have integer, for example, integer r, then it is okay, it do not match with this volume here, because in this part the capital R is double, and somewhere here if you have integer then it will be conflict. Okay, so it should match, okay, in their argument types and prototype. Okay, so similar to this one, we have surface area double small r here. Okay, so the small r is double, so it match. Okay, so the data passing, okay, should satisfy these three rules. All right, let's do one exercise here. Okay, construct a class name called polar coordinates containing two double precision data members, name, distance, and theta. Okay, so first of all, so this this exercise basically wants to convert the Cartesian coordinates to polar coordinates. Okay, so what we can see here, it is stated here, construct a class name polar coordinate. Okay, so it means that this is the class name. Okay, containing two double precision data members, name, distance, and theta. So this distance and theta are the members. Okay, so these two members. Okay, basically to store the distance and angle. So the distance is r, the angle is theta. And then the member function should include constructor. So we have the constructor, and we might also want to have the destructor, and display functions. Okay, and a function name convert to polar. Okay, so this convert to polar is our function. So this is function in the class polar coordinate. The convert to polar function should accept two double precision numbers representing a point in Cartesian coordinate x and y. So this x and y should be the input data to the function convert to polar. Okay, so those are the things that we need to have in the class. Okay, so basically roughly we have the class polar coordinate. Okay, so inside the class we have the distance, we have the theta, and we most likely to have x and y as well, because the whole idea of this program is to convert x and y reading to the distance and theta. And we also have the constructor. Constructor should be the same name as the class, so polar coordinate here. Okay, and we also have the destructor, so polar coordinate. And also we have the function. So inside the class polar coordinate, we have the convert to polar. Okay, roughly those are the things that we need to have. Okay, but I didn't put the data type yet. Okay, so it should be the double here, and this one we need to think whether it is double or just void. Okay, so we'll see how do we construct everything here in C++ programming. Okay, now this is the skeleton program, okay, of our problem just now. Okay, so we have the class polar coordinate. So inside the class, we have the variables, distance, theta, x, and y. Okay, so I put everything with a public, okay, public mode. And we also have the constructor, polar coordinates, destructor, tilde polar coordinates, and we have one function which is convert to polar. Okay, so I just put here void or double. Okay, so after this we need to decide whether it is void or double. Okay, so how do we decide between void and double? Okay, so if the function return a value, then it should be double. If the function do not return any value, then it's just void. Okay, so now look at the destructor part. Okay, so basically you just write your class name follows with a double colon, and then again the constructor name, which is the same name as your class name. Okay, so if you don't have anything to be declared in the constructor, so you just put the open and close quote. Okay, the same thing to the destructor, so we just put the destructor here so that the program will release the memory after we execute the program. And then the function convert to polar, so we have here the polar coordinates, okay, double colon, convert to polar. So now let's take care of the function convert to polar. So basically this function will convert the Cartesian coordinates. So we can imagine we have the input, okay, in terms of Cartesian coordinates, x and y reading. Okay, so the input here should be two values, x and y, which have the data type double. Okay, so we have double x comma double y. So those are the data types. So when we have this data type, it should be tally with what we have in the class. Okay, so it should match here, the rule of data passing. So we need to write here double. Okay, we just put the type of data type only, double and double, okay, without the x and y. Okay, so now in this function we want to convert x and y to the distance and theta. So distance is given by the square root, okay, the formula that you have in the problem just now, square root of x squared plus y squared. So you can see here, you can directly use the x and y and also the distance because they're already declared as public here. You don't need the linking operator. So the same thing for the theta. So theta is the inverse tangent. So in C++ it is a tan. Inverse tangent y over x. Okay, but you can see here you still have the curly lines, okay, which indicate the error, okay, because okay we still do not decide on the void and double here. Okay, it is wrong to write two words void and double here. Okay, now so okay now you can see in the function convert to polar here. So at the end of the process, we have two values, distance and theta. Okay, so now the question is, should we have the written here? Okay, just like in a previous code just now, you have the written R, written V, and so on. Okay, so in this case, you have two values, distance and theta. Okay, so you must aware, or you must remember that the written value cannot be more than one. You cannot return two values in a single function. So it cannot be written in this case. Okay, if we don't have written, then it will be just void. So if we use void here, it should be tally with what we have in the declaration of our class. So we just use the void. Okay, so you can see you don't have the red curly lines anymore. Okay, so that's the distance and theta. Okay, so this convert to polar, okay, require the input x and y. Okay, so now who or which function that might use the convert to polar, or which function might call for this one? Okay, so it is most likely the void main here, our main processing area. Okay, so in the void main, okay, we want to call, so basically we have the input in terms of Cartesian. Okay, in the void main, we want to convert that into the polar coordinates. Okay, so for this case, we are going to assume that we have a fixed value of Cartesian. For example, we have the x and y reading as so let's take 1.2 and 3.5 for example. Okay, so I'm going to write double A equals 1.2, B equals 3.5. Okay, we have a fixed value, right? And now we want to convert this 1.2 and 3.5 to be a distance and theta. Okay, so we know that we should call for convert to polar function. Okay, so convert to polar function is a function in the class polar coordinates. So in order to call this function, we need to have a linking operator. Okay, so before we use the linking operator, we need to declare one object. Okay, so in the class polar coordinate, so I'm going to declare one function P, one object, not function, it is object P, so that I can link P to any function that we have in the class polar coordinate. Okay, so now P, so now I can call the convert to polar. Okay, so the convert to polar require two inputs, double x, double y. So here, okay, convert to polar here should have two inputs as well. Otherwise, it will be conflict. Okay, so since we want to convert 1.2 and 3.5, so we put that directly inside the bracket. Okay, so it means that this p dot convert to polar will carry 1.2 and 3.5 to this function here. Okay, so at the end of this line, your program will go to this. So whatever value that convert to polar carries will be the value of x and the value of y. Okay, so when it comes to here, your program will automatically know that x is 1.2 and y is 3.5. Okay, so it will compute the distance is equal to the square root of 1.2 square plus 3.5 square. Similarly, for the theta, it will compute the inverse tangent of 3.5 over 1.2. Okay, so to make it meaningful, then we should have a display message. Okay, display output. Okay, so we want to display the distance and theta, so we just put the C out here. Okay, because we cannot have a written value, so we cannot have the C out here. Okay, so it should be here. So C out. Okay, so let's display the Cartesian first. So C out the Cartesian coordinate is, so we want to have the x. Okay, so here is x. Okay, you can use directly because they are public. And then comma, so it should be in the code. Okay, comma, and then we have the y. Okay, so E and the L, and then see out the polar coordinates. Okay, I'm just copy here the polar coordinates. Okay, the polar coordinates is now the distance, comma, the theta. All right, so let's see whether it's working or not. Okay, so you have that. The Cartesian coordinate is 1.2, 3.5, and the polar coordinates is 3.7, and the angle, okay, 1.2405. Okay, so that's how do we apply the class and also the data passing, okay, between functions in our program. Okay.